Good evening all. We were discussing third module. In that, we have seen the need for transmission as well as the one-line diagram of a power system. Next, we shall see the main parts of overhead transmission lines. First of all, the conductors. The conductors are responsible for transporting power from one location to other. The primary function of transmission line conductor system is to transfer electrical power between the designated locations within the prescribed performance, operating and environmental conditions. Secondary functions of transmission line conductors are to maintain electrical safety, safely transfer the power from one location to other, provide a cost-effective service. Conductors must be of proper size, that is cross-sectional area. The cross-sectional area of a conductor depends upon its current carrying capacity. Usually ACSR conductors are used. ACSR means aluminum conductor, steel reinforced. Then another component of transmission is the mainly the substations. There will be step-up substations as well as step-down substations. The heart of a substation is called transformer. Step-up transformers are used for stepping up the voltage level, and step-down transformers are used for stepping down the voltage. Transformers permit power to be transmitted at higher efficiency. That is, at the generating station itself, we are having a step-up transformer that raises the voltage to a higher level so that the current is being reduced. Then the power is transmitted over long distance. That is called primary transmission section. In that section, the I squared R loss will be minimized due to reduction in current. So, efficiency of transmission is being improved by this action. Next is line insulator. Line insulators are actually separating the tower from the transmission conductors. We know that transmission conductors are carrying the power and they are supported by means of metallic towers. Then, if there is electrical contact between the conductor and the tower, power will be grounded. So, in order to avoid that, between the tower and the conductor, we are having the line insulator. The line insulators mechanically support the line conductors while electrically isolating them from the supporting towers. That is to insulate energized components from the earth structures, that is towers, at rated operating voltages and specified switching and lightning impulses. Then to support the conductor system up to ultimate mechanical load limits and transfer the mechanical loads to structure. Then support towers. They are used to support the line conductors suspending in the air overhead. The primary functions of transmission tower structures are to provide mechanical support to the conductors. The secondary functions of transmission line structures are to ensure the safety of people and environment. They maintain structure geometry to preserve the maintenance safe approach distances for service. Then they provide an electrical path to earth pole for fault currents. So by means of the tower, the earth wire that is driven along with the conductors that are carrying power, the earth wire will be carrying the lightning surges as well as switching surges, and at each tower this earth wire is being grounded. So they provide an electrical path to earth for fault currents. Then provide a cost-effective service. Then provide electrical clearances. So there should be sufficient clearance between the ground and the power conductors in order to ensure the safety of people and the surrounding. Then protective devices are also there in transmission section. In order to protect the transmission system and to ensure reliable operation, we are having the protective devices. Protective devices include ground wires that are driven along with the transmission, then lightning arresters, circuit breakers, relays, etc. Then transmission line earthing. This is also a protective measure. It provides an electrical path for lightning and fault currents to earth. We have the earth wire on the top of transmission. Then at each tower, this earth wire is being grounded. So by earthing, we provide an electrical path for lightning and fault currents to ground. The earthing can ensure safety of people, assets, and the environment. Then it ensures that faults are cleared within time limits. Transmission line components are not being damaged. Then voltage regulators. Due to drop in the transmission line in the form of I into R, current into resistance, there may be a reduction in voltage at the receiving side. So IR drop is caused due to the current carried as well as the resistance of the transmission line. Then at that time, the sending end voltage may not reliably reach the end consumer. So in order to avoid this drop or in order to compensate this drop, we need voltage regulators. They will adjust the voltage to the consumer requirement. So voltage regulators keep the voltage within the permissible limits at the receiving end. So with this, we shall conclude, and in the next class we shall study about the conductors as well as supports that are used in transmission. Thank you.